In our last video, you were supposed to try to complete these on your own, so I'm just going to post the work and quickly go through each one to make sure that everything works out for you. So we want to start by squaring both sides since the root is isolated. Remember, when you square the right side, you have to put it in parentheses with the squared outside and then FOIL it out. And then since we're solving a quadratic, we want the problem to be equal to 0. So I'm going to move the 10x and the 9 over. And then this is going to be a really simple problem to solve because all you have to do is just factor out the GCF, and now the problem's factored. And so I'm going to set my GCF equal to 0 and x minus 4 equal to 0, and I get two answers. Now you would have to check them because you did square both sides. So I'm going to check 0 first by plugging it back into the beginning. And then I'm going to check 4. And what you'll find is both 0 and 4 do work. So we want to keep both of those solutions. Number 6, you can just start by squaring each side. It makes each root go away. And then we just solve it like a normal algebraic equation. We get 2. And again, we do want to check it because we did square both sides. So we have to plug 2 back into the beginning and verify that. And it does work. Now number 7 is going to be the most work involved because you have two different roots and you have a subtraction problem, which means you're going to have to FOIL with a root. So before I put parentheses around this side and square it, I'm going to go ahead and replace x plus 6, root x plus 6 with an a, just to save myself a little writing. So this would be what my new problem looks like. Then we're going to FOIL both sides. Excuse me, we're going to FOIL the left side and square the right side. So when I FOIL the left side, that's what I get. And then I want to go ahead and replace my a back in. Now if you notice, I did not use the square root because I saw there's a squared right here. So the square and the root are going to cancel each other out. You're just left with x plus 6. Once you do that, you kind of have to start the process all over. You have to get this root by itself. So the x, the 6, and the 4 all need to get moved over to the other side. And that's going to leave you with negative 12. And then we want to divide both sides. Square both sides. So you get 3. And then you do have to check it since you did square both sides. So we have to plug 3 back into the beginning. And it does work. The word problems are actually a lot easier than like the last problem we just did because they're giving you a formula. They're telling you what your variables stand for, and then they're asking you to put something into the formula. So we know that V stands for wind velocity, P stands for air pressure, and they give you this formula. And they're saying, what would P be if velocity was 54.5? Now you have to remember, this right here is function notation. This means the velocity based on a certain pressure. So it's not saying velocity times pressure. So I could just as easily just write 1v right here and not even use the p. So I just want to take this formula and set it equal to 54.5 and then solve it from there. So we'd want to divide off the 6.3, square both sides, and then solve for p. Now normally you would have to check this because you squared both sides. However, since it's a word problem and you only got one answer and they're telling you there's an answer, you know that this is going to work because there's no other possible answer to this problem. All right, we'll take you through 3 more examples here. So what this problem says is basically the square root of x plus 30 equals x. So the first thing I'd want to do is square both sides, and that leaves me with this. And again, I want one side to be 0. I can solve using quadratic formula or factoring. Factoring is going to be quicker. And so I get 2 answers, 6 and negative 5, but because I squared both sides, I need to check those answers. And to save on time, I'm just going to let you know the negative 5 is not going to work out. For the next problem, I'm going to go ahead and move the negative 6 over because that's definitely not part of my radical. And what I'm going to do is I'm going to change this into radical notation. So I'm going to change it into the cubed root of all of this to the 5th power, since that's what 5/3 means. Now the negative 5 is not part of the root, so we want to divide that off and get 1024. The next thing to leave would be the cubed root, so we're going to have to cube both sides. Now I'm going to leave this as 1024 cubed because that's a really big number, and sometimes if our numbers get too big, our calculator can't show us the whole number, and truth be told, we don't need to write out what that is because part of it's going to go away. So I just want you to leave it like this for now and just keep working. So we want to get rid of the 5th by 5th rooting. And now if you type into your calculator the 5th root of 1024 cubed, it will tell you 64. And then you can finish solving from there and you get 14. Now we do not need to check this answer because we cubed each side. We had an odd root, so we don't have to check that answer. Now on the last problem, the root is by itself, so I want to begin by cubing each side. That is going to involve some FOILing because this is a subtraction problem. So I put this in parentheses with the cubed outside. And you have to remember what that means is you're basically doing 2x minus 1 times itself times itself. So the way we handle that is we're just going to work with the first two groups. We're going to FOIL that out. And this is what we get. Now what we do from there, we're going to take this 4x squared and we're going to distribute it to the 2x and the 1. And then we're going to use the negative 4x and distribute that. And then we're going to use the 1 and distribute that. So you should get basically 6 things whenever you multiply this out, because each of these is going to 2 different things. So if you do 4x squared times 2x, you get 8x cubed. 4x squared times negative 1 is negative 4x squared. Negative 4x times 2x is negative 8x squared, and so on. And I'm going to treat this like a quadratic problem. I want everything to be equal to 0 so that I can try to use a method to solve it. So I'm going to move over the 8x squared. I'm going to move over the negative 1, and I'm going to combine my like terms, which conveniently leaves me with negative 12x squared plus 6x. There's no need to use the x method to factor it or quadratic formula because you can just pull out the GCF. So I'm actually going to pull out a negative 6x. You could use positive 6x, but I always like my x squared term to be positive, so I use negative 6x. And that leaves us with 2x minus 1. And then we want to set each of these equal to 0. So I'm going to get 0 and 1/2. I don't need to check either of these because I had an odd index, so these are both going to be legit answers.